Hello students, in this module we are going to see integrals which are having higher power of sine and cosine. And these powers are odd in nature. Let's take the very first integral here. The integral is integral of sine raised to 5x dx. Now 5 is an odd number, we have sine raised to an odd number. So let us see how to evaluate this particular integral. So after copying the question, my dear students, what do we need to do? The step or the method for evaluating higher powers of sine where the power is odd is very simple. Break the odd power. What do you mean by that? Break the odd power into an even component and an odd component. That is, we'll write sine raised to 5 as sine raised to 4 into sine x dx. So that sine x is the odd part and sine raised to 4 is the even part. Now my dear students, the method after this is that sine x is derivative of which function? Can I say sine raised to 4 is sine square x the whole square and sine x is there as it is. Now you have to ask yourself, sine x is derivative of which function? Now we know that sine x is nothing but derivative of cos. We ignore the minus part of it. Sine x is derivative of cos. So what you have to do is leave this sine x as it is and the remaining function there you have to convert in terms of cos. So what we will do is write sine square x as 1 minus cos square x and that will be whole square as it is and sine x will be there. Now my dear students, what we are doing in the process, we are writing the integral in the form of a function and its derivative. So we can go ahead and substitute. So in the next step, what I am going to do is the substitution. The substitution will be cos x is t, and because we have already made provision for sine x, we can differentiate and write sine x dx is minus of dt, correct? So the integral will look like 1 minus t square the whole square into minus of dt. Now 1 minus t square the whole square cannot be directly integrated, it needs to be simplified. Right, so we'll write this as 1 minus 2t square plus t raised to 4 into minus of dt. That is nothing but minus 1 plus 2t square minus of t raised to 4 dt, correct? My dear students, now this is what we need to integrate. If I integrate this, the very first term will give me minus t, then the second term will give me 2t cube by 3 and minus of t raised to 5 by 5 plus c. Now we have to give the answer in terms of x. We need to resubstitute. So what was t for us? T was nothing but cos x. So let us resubstitute. So the answer will be minus of cos x plus 2 cos cube x by 3 minus of cos raised to 5 x by 5 plus c, and that's your final answer. This is how we tackle odd power of sine and cos. Same has to be done for cosine as well, my dear students. Now let's take the next question in an MCQ format. Before that, you may try these questions for your practice. As I've given you here, cos raised to 5, you can try that. Cos cube and sine cube can also be tried in a different manner as we have seen in 11th standard. Now let's take a question from the entrance part of it. Here what is different is you are seeing two different functions, both sine and cos multiplied in an integral. Idea does not change. Break the odd power if at all it is present. So what we are going to do in this case is break that cos cube. Cos cube will be written as cos square x into cos x. So we will leave the cos x aside. Cos x is a derivative of sine. So our job will be to write the remaining part of the integral in terms of sine. Leave the cos x aside. This cos x you leave it aside. So what we'll do is sine square x into 1 minus sine square x into cos x dx. Now we have a function of sine and derivative is also present. So we can go ahead and substitute. So let us write, let sine x is equal to t. Cos x dx will become equal to dt. So the integral will look like 1 minus t square into t square dt, correct? I need to multiply that t square inside. So we get integral of t square dt minus of t raised to 4 dt. That is nothing but on integration will give me t cube by 3 minus of t raised to 5 by 5 plus c. Now the options are in terms of x. because t was substituted as sin x. So let us see which option is giving us the answer. If you check very carefully, my dear students, if I put t as sin x, we get option C as the correct answer. So my dear students, option C is your answer. This is how we tackle sums where odd power of sine and cosine is involved. That's all we have in this module. Thank you very much.